Now, good morning, class. Good morning, everybody. Now, this morning for today class, I'm going to start with introduction to algebra. And when we are talking of algebra, we need to talk about indices. Yes, we need to talk about indices. So, let's talk about indices. Indices. Now, and um, indices as you before you can solve a question or a problem under indices, you must have to know the rules of indices. There are many rules under indices. Now I'm going to start with the laws one by one. Now let's start with law one. Law of indices. Now the law one, I call it law one. Now, the law one of indices, I name it what? In some textbook you will see they write multiplicational law. So I also call it what? Additional law. So multiplication law or addition law. Now, why do I call it multiplication law or addition law? Now, the reason why I call it multiplication law or addition law is because in indices, that is what we call you reverse. In indices, this sign here, this mathematical sign here, multiplication, we change to what? To addition. And likewise, the addition will also change to what? To multiplication. So you can call it multiplication law of what? Of indices, or addition law of what? Of indices. And also, I must have to draw your notice to something. In indices as a whole, we deal with power. Yes, another name for indices is what? Is power. You don't want to call it indices, you call it what? Power. Indices is the plural form of index. Now, let's look all indices question. Let's look at this form. This is x raised to power a. This x raised to power a, and this a is what we call what? The power or the index. We call it the power or the index. Why? This x here is what we call the what? The base. The base. So the x here is the base, is the one carrying the power. Am I communicating now? Is the one carrying the power. Now let's now state the law of indices. Now the law of indices, the law one of indices. Law one of indices states that the law one of indices states that when same base is carrying power, and in between the bases you have multiplication sign, then the power will be added up. Yes. Now let's look at it mathematically. Now this x raised to power a times x raised to power b. Now as you can see, as we just stated the law one, we said multiplication law or additional law states that when same base same base. Now look at this. This is x and here is x. Now the both of them is having what? Same base. Now when same base is carrying, carrying a power, can you see the x here is carrying a power and the second base here is also carrying a power. Now he said, and in between them you have the what? The multiplication law. Then the what? The power will be added up. Now let's look at the example. E.g., we have x raised to power 3 times x raised to power 2. Now, following the law 1 of the indices, since the two bases are the same base, mind you, I've given you here a clue that a here is the power, while x here is the base. Now, since the two of them are of the base, then we say we have x. Following what the law is talking about, the law say we should add the power together. That means here x here multiplication rather is changing towards to addition. Multiplication is changing towards to addition. There will be some cases we want to refer to whereby addition we now need to change the addition back to multiplication. That is, if we are talking of exponential indices, we are still going back to that. Now here we say 3 plus 2, which will give me what? X raised to power what? Raised to power 5. Now let's look at this type of example. Under example again, example 2, if I have x raised to power 3 multiplied by what? Y raised to power 2. Now, when you look at this kind of example, following the law of indices, the law of indices said that we have, I repeat, we have to consider this law when the bases are the same. Now looking at these two, the bases are never the same. Now this is base x. This is what? Base x. Y. This is what? Base y. Now do you see the two bases are never the same? Now with this, we come to the conclusion that we can't use what? The law 1 of indices to solve this question. Now, so we have the answer to be x raised to power 3 times y raised to power 2. Now, we still have some complex questions. Let me have my board cleaned. We still have some complex questions. Let's look at example 3. Example 3. Example 3 here under law 1. Example 3 under law 1. If we have 2x raised to power 3 times 5x. Now, when you want to solve this, you look at this kind of question carefully, because you look at it that the x now is having a coefficient. Yes, the x is having a coefficient. The coefficient of x raised to power 3 here, the coefficient of x raised to power 3 here is 2. Why the coefficient of x or x raised to power 1, you can call this mathematically x. You can also call it what? X raised to power 1. Any of the two. Now, the coefficient of x here as it stands now is 1. Why the coefficient is, if you want to call it x raised to power 1, is 1. Now, the law 1 of indices always states that when the basis is the same, then we change the multiplication sign to addition to the what? To the power. Now, let's look at this now. This is a coefficient of 2 and a coefficient of 5. These 2 and 5 will only be affected by the sign of what? Of multiplication. So we have 2 times 5. Are you with me? So we have what? 2 times 5. No. times what? X. We'll be left with what? X raised to power 3 times x raised to power 1. Am I communicating now? Now you are bringing out the coefficients. Am I communicating now? So this 2 times 5 will give me what? Will now give me 10x. Now when you look at this power now, the bases are the same now. So with these two bases now, we now say we are picking one of the base as we've just done in the previous examples. Now picking one of the bases, you now have 3 plus 1. That means because of the law 1, we have to add up the power since they are having the same base. So we have 10 raised to power 10x raised to power what? 4. Are you with me now? So let's have a break, then we come for more examples under law 1, then before we move to law 2.